Hello and welcome to this lesson on atom economy. In today's lesson, we will first learn what atom economy is and why it is important for sustainability and economic reasons. Secondly, we will learn and understand how to calculate atom economy. So far, we've covered the fundamental concepts of the mole and relative formula, or atomic mass. You now understand how to use these concepts to determine the amount of substance and the mass of individual atoms or molecules in a chemical reaction, and you can calculate percentage by mass. Building on this foundation, today's lesson will introduce the concept of atom economy. This new idea will advance our chemical understanding by helping us evaluate the efficiency of chemical reactions, not just in terms of yield, but also in terms of how well we utilize the starting materials. This insight is crucial for developing more sustainable and economical chemical processes. Atom economy is a measure of how efficiently a chemical reaction converts reactants into useful products. Imagine making a sandwich. If you use all the ingredients you bought, like bread, cheese, and ham, without any leftovers, that's like a high atom economy. But if you have lots of extra crusts or scraps you can't use, that's like a low atom economy. It's about how much of your ingredients or reactants end up being part of your useful product or sandwich. To put it simply, atom economy indicates the percentage of the total mass of reactants that end up as the desired products. This is crucial for several reasons. The first is sustainable development. Reactions with high atom economy generate less waste, making them more environmentally friendly. They help in conserving raw materials, reducing the demand on natural resources. The second are the economic benefits. High atom economy means most of the starting materials become the desired product, which translates to cost savings. Less waste also means less expense in dealing with byproducts and waste management. Now, let's move on to how we calculate atom economy. This is the formula. Atom economy equals mass of desired product divided by sum of masses of reactants multiplied by 100%. Using this formula, you can determine how efficient a reaction is. Let's go through an example to illustrate this. Consider the production of ethanol by fermentation of glucose as an example, which produces carbon dioxide as a side, undesired product. Step 1 is to identify the desired product. Here, it is ethanol. Step 2 is to calculate the relative formula mass of ethanol. Carbon has an atomic mass of 12. Hydrogen has an atomic mass of 1. Oxygen has an atomic mass of 16. Calculating the relative formula mass of ethanol leaves us with 46. Since the equation shows we produce 2 moles of ethanol for every mole of glucose, multiply this number by 2, giving a mass of 46 times 2 equals 92. Step 3 is to calculate the sum of the relative formula masses of the reactants. In this case, we only have one reactant, which is glucose. Calculating the sum of relative formula masses gives us a total of 180. And finally, step 4 is to substitute the values into the above formula. Atom economy equals 92 divided by 180 times 100% is approximately equal to 51.1%. This tells us that the reaction has an atom economy of 51.1%, meaning just over half the reactant mass is utilized to form the desired product, making it not very efficient. In summary, understanding and calculating atom economy helps us appreciate the efficiency and sustainability of chemical reactions, guiding us towards more environmentally friendly and cost-effective industrial processes. Reactions with high atom economy are more sustainable and economically beneficial because they maximize resource utilization and minimize waste generation. This can lead to reduced environmental impact and lower production costs, making such processes more competitive in industrial applications. Let's dive into some GCSE level questions to apply our understanding of atom economy and its calculation. Calculate the atom economy of the reaction where calcium carbonate decomposes to form calcium oxide. Carbon dioxide is also released in this process. The first step is to identify the desired product. Here, it is calcium oxide, written as CaO. Next, we need to calculate the relative formula mass of calcium oxide. Calcium has an atomic mass of 40, and oxygen has an atomic mass of 16. Therefore, calcium oxide has an atomic mass of 40 plus 16, which equals 56. Now, calculate the sum of the relative formula masses of the reactants. Calculating this gives us a total of 100. Now, we can substitute the values into the formula. Atom economy equals 56 divided by 100 times 100% approximately equals 56%. This tells us that the reaction has an atom economy of 56%, meaning 56% of the mass of the reactants is converted into the desired product, calcium oxide. Now, let's look at an example of a reaction with multiple reactants. Hydrogen can be manufactured by reacting methane and steam. Carbon monoxide is released as a byproduct of this reaction. First, identify the desired product. Here, it is hydrogen. Next, calculate the relative formula mass of hydrogen. Hydrogen, H, has an atomic mass of 1. So for H2, we do 1 times 2, which equals 2. The equation shows we produce 3 moles of H2 for every mole of ethanol reacted. So we need to multiply this by 3, giving a mass of 2 times 3, which is 6. Now, calculate the sum of the relative formula masses of the reactants. Carbon has an atomic mass of 12, and hydrogen has an atomic mass of 1. So for CH4, relative formula mass is 12 plus 1 times 4, which equals 16. Hydrogen has an atomic mass of 1, while oxygen has an atomic mass of 16. For H2O, relative formula mass is 1 times 2 plus 16 equals 18. The sum of relative formula mass of reactants is 16 plus 18 equals 34. When we substitute the values into the formula, we get the following. Atom economy equals 6 divided by 34 times 100% approximately equals 17.6%. This tells us that the reaction has an atom economy of 17.6%, meaning 17.6% of the mass of the reactants is converted into the desired product, hydrogen. In today's lesson, we learned about the concept of atom economy and its significance in both sustainable development and economic contexts. We defined atom economy as a measure of the efficiency of a chemical reaction in terms of how well atoms are utilized to form the desired product. This is crucial because high atom economy means fewer waste products and better resource utilization. We also learned the formula for calculating atom economy, and then worked through a step-by-step process of calculating it. By the end of the lesson, we had a solid grasp of what atom economy is, how to calculate it, and why it is a key consideration in modern chemistry for both environmental and economic reasons. This knowledge is fundamental as we move forward in our study of quantitative chemistry and its applications.